Contabulate now has a new kind of mapping available in bindings called an expression mapper. This is definitely an advanced feature, but it lets you do some interesting things and some things that aren't possible with the existing binding mappers. So just to recap a little bit, a binding is made up of a source object and binding point and a target object and binding point. And depending on what type of objects you have selected here, that determines the types of mappers that are available over here. Now the expression mapper is available on all binding points. So no matter what you have selected here, the expression mapper will be available over here. So just as a simple example, if I was to take the master level output gain and map that to the master level input gain, not something you would normally do, but it's a good example. You'll see that there's this range mapper here. Okay, it's the one that's been automatically selected. These are the available mappers. And what you can see here is this has just mapped the input value, sorry, the output gain to the input gain. Okay, so you can see they're both locked together. Now, what I can also do is I can select this expression mapper. And what that lets you do is type in basically math expressions in here that control how the binding works. So to simulate that direct mapping that we had before, I could just say that the result is equal to the input. So the input here is the value that comes from the source binding point, and the result is the value that's sent to the target binding point. So you can see now I've got that same behavior by sending the input to the output. Okay, it's a little bit confusing because I'm using the word input here twice as the input gain and as the value to this expression, but they're separate things. So what I can do now is I can put maths expressions in here. So if I was to say divided by 2, for example, you can see now that the gain level of the input is half of the output. It doesn't look like it because this is a logarithmic scale, but that's actually what it is. Similarly, I could do times 2. Again, this is not something you would ever realistically do, but it's a good example of how this expression mapper works. Okay. Now the other thing you can do is these conditions here, which control when the target is invoked. Now for something like this, which is a value to value mapping, normally you would just want that to always be true. But for example, if I was to go into here and choose execute command and write log message, this is a good way to test how a binding point is being invoked. So whatever I put in here, whenever this target is invoked, it'll be displayed down here as a log message. It's also written to the log file, but this is a good diagnostic tool for testing bindings. So if I was to put in here, for example, received $value at $tick count, what this will do is every time this binding point receives a message, it'll receives a value, it'll display what the value is and when it was received. Okay, so I've just got a direct mapping there at the moment, and we're still mapped to the master gain. So you can see there, this is the gain level as it's set, and the tick count shows you that it's received a new value. So see that tick count value at the end there is ticking over, indicating that every time I move this value is getting updated. Okay, if we were to switch over to the expression mapper, again I can put in input there and we've got the same thing, but now we're getting a log of what's actually happening. So you can see there, that's exactly the same. Again, I can do my maths expression on here if I want to, but I can also do things like, for example, if input is greater than 1, then say loud, otherwise say quiet, for example. And you'll see now when it's below 0 dB, it's saying quiet. You can see here, received quiet. Okay, so that's the string that's getting sent to there, the quiet or loud string. And then when we go above 0 dB, which is the value 1, unity gain, then we get received loud. Okay, so we're doing some simple conditional logic there. Now, what you might want to do is you might want to only trigger this binding point when the value actually changes. So in here you can put to only invoke, so this fire option says when this mapper fires to the target. You can say always, which is every update gets sent through. You can also say to only, if I was to say when the input changes, for example, every time this changes, the target will get bound. So that's kind of the same. Okay, again, you can see that tick count's updating every time. But if I was to say to fire when the result changes, then it will only fire when this string changes from loud to quiet or vice versa. Okay, so when I go above 1 dB, 0 dB, you can see there it went to loud, quiet, loud, right? And it's only firing when I transition across this 0 dB point. Okay, so that might be useful, for example, if you're trying to write out a log message, or you're trying to send a MIDI event to something and you only want to send it when it actually changes. Similarly, you can put a condition in here which is used for if you wanted some other condition to decide when this thing fires, for example. So for example, you might only want this, just as another random example, if the input value is greater than 0.5, then fire when the condition becomes true. So in this case, this will only fire when the input goes from below 0.5 to above. Okay, so if we do this, you'll see now. Okay, so it went to quiet, and you can see it's only firing now when it goes above. I can also say fire whenever the condition changes. So in other words, whenever this changes to above 0.5 or below 0.5, then it will fire. And again, you'll see the same thing. Okay, see that tick count updates when it transitions above, below. So there's a whole lot of combinations of things you can do here. Some of these are equivalent to each other. So for example, if I was to put in here if condition is true, I can simulate a, let's just put in here, for example, loud. I can simulate this displaying loud when the input goes above 0 dB by putting if the input is greater than 1 and the previous input, which is another variable. These two variables are available here, by the way, input and previous input. And the previous input was less than 1, less than or equal to 1. Okay, so when the input goes above 1 and it was previously below 1, and that's an edge detect condition, fire if it's true, and you'll see you'll get the similar behavior. Okay, so it received loud. If I go below, it doesn't do anything. It's only when I cross from that below to above that it fires. Okay, so there's endless combinations of things you can do here. Where this gets really interesting is that these variables here, you can actually look at the on-screen keyboard variables. So you can actually look at the current value of a CC or any of these attributes of the on-screen controller, which lets you sort of, it provides an avenue for combining the actions of several bindings together. So for instance, you might have one binding that writes a value to a CC and then another one that acts depending on whether it's set to some value, for example. It's not exactly what this was designed for, but it wouldn't be the first time that things in Cantabile have been bent to do things they weren't designed for. So there's some interesting possibilities there, and yeah, this is just a new kind of mapping. It's definitely an advanced thing. Normally you won't need it, and the standard mappers that are available here do the job. But yeah, at a pinch, if you're stuck, you can probably get away with building just about any of the other binding points, I think, using just these few things here.